You were asked tonight to look at 8 different rational functions and to identify, not graph, but identify the horizontal and the vertical asymptotes, along with identifying the x and the y intercepts if they existed. So let's get started. Let's start with the horizontal asymptote here. Recognize there's no x on top, so it's really x to 0. So I have a 0 on top and I have a 1 on the bottom. When the degree in the numerator is less than the degree in the denominator, we will always have the equation for the horizontal asymptote of y equals 0. And I can come back here to see that. When the degree in the numerator is less than the degree in the denominator, we always get y equals 0. Let's move on right now to the vertical asymptotes. So the vertical asymptote, by the way, when I look at this function, I'm not able to simplify it any further in order for me to reduce anything. So let's look at the vertical asymptote. I'm going to take the denominator, set it equal to 0, and to solve, and I end up with x equals 3 being the equation of the vertical asymptote. All right, now how do I determine the intercepts? So to determine the x-intercept when it's in this form, there's no additional numbers in back. That's the key. There's no additional numbers in back. We'll see those in example 7 and 8. So in this form, to identify the x-intercepts, the trick is to take the numerator and set it equal to 0. Well, setting the numerator equal to 0, that's not a true statement. 0 doesn't equal 6. That means there is no x-intercepts. Now, if you don't remember that trick, hopefully you remember that when you find the x-intercepts, y equals 0. So I'm going to replace f of x with 0. And then I'm showing you the longer way of achieving the same answer here. I'm going to cross multiply. 0 times the quantity x minus 3. Well, 0 times anything is 0. 1 times 6 is 6. And you can see we still get a statement that's not true. That's why no x-intercept exists. How do we determine the y-intercept? For the y-intercept, I'm going to replace the x with 0. So y equals 6 over 0, subtract 3. Y equals 0 over negative 6, and we have a y-intercept of negative 2. Let's look at the next example. Now here it looks like there's a possibility that I can go ahead and factor this. So I'm going to write y equals, I'm going to factor order 2. And then I'm asking myself what two quantities multiplied equal negative 15 and combined to give us a positive 2, x plus 5 and x minus 3. I can still rewrite this. I know x squared minus 16 is going to be a difference of squares, so x plus 4 and x minus 4. All of this is beautiful, but it doesn't allow me to simplify anything, which means there is no holes in this graph. Let's start with identifying the horizontal asymptote. So the degree in the numerator is equivalent to the degree in the denominator. And when that occurs, when they are equal, we're able to achieve the horizontal asymptote by creating a ratio. And our ratio is going to be created by y equals whatever the leading coefficient in the numerator is divided by the leading coefficient of the denominator. So here's the equation of the horizontal asymptote. The vertical asymptote is going to be achieved by taking the denominator. In this case, we have a product of linear factors, and we're going to take each one of those and we're going to set it equal to 0 and solve. So x plus 5 equals 0 and x minus 3 equals 0. And now we're going to come up with 2. X equals negative 5. That's one equation. And x equals positive 3. Those are our two equations for the vertical asymptote. Once again, there is no hole in the graph. How do we determine the x-intercept? So for the x-intercepts, we take the numerator and we set it equal to 0. I can either use this form or this form. So 0 equals 2 times x squared minus 16. Well, first I'm going to divide by 2. 0 divided by anything is 0. Then I'm going to add 16 to the opposite side, plus 16 and hold up here. So 0 plus 16 is 16. I can see I'm going to have two different answers. I'm going to have plus or minus the square root, so a square root of 4. So there's two x-intercepts. One's at 4, the other is at negative 4. Two x-intercepts. Now let's identify the y-intercept. To achieve the y-intercept, I'm going to set x equal to 0. And I think in this form it's so much easier to do it algebraically. So I have 2 times, well, 0 squared is 0. On the bottom, 0 plus 5 is 5, and 0 minus 3 is negative 3. Okay, 2 times negative 16 is negative 32 over negative 15. So y equals 32 over 15. That is going to be the y-intercept. Let's look at our next one. Looking at example number 3, excuse me, from the homework. Let's first go ahead and let's factor it. So let's factor out a 2. And then I can factor out an x. And we can see that I'm not able, so I now wrote this as a product of linear factors. I'm not able to reduce anything, so there's no holes in the graph. But let's go ahead and examine the degrees. The degree in the numerator is less than the degree in the denominator. And when it occurs, as a reminder, when the degree in the numerator is less than the degree in the denominator, we will always have a y-intercept of 0. So my horizontal asymptote is y equals 0. Not just 0, it's the equation y equals 0. What is the vertical asymptote? Well, the vertical asymptote is I get to take these two parentheses below, the factors below, and I'm going to set each equal to 0, and I'm going to solve. Well, one's already solved for, and when I subtract 4 to the opposite side, the other is negative 4. So I have vertical asymptotes at x equals 0 and x equals negative 4. Let's move on now and let's identify the x-intercepts. So to find the x-intercept, I take the numerator and I set it equal to 0. Either one of these numerators would work. So 0 equals 2 times x plus 2. Dividing by 2, well, 0 divided by 2 is 0. And then I'm going to subtract 2 from each side. Negative 2 equals x. Negative 2 equals x. That is going to be our x-intercept. How do we determine the y-intercept? To determine the y-intercept, we're going to replace we're going to replace x with 0. So y equals, I prefer this form to do it quicker, but that's just my preference. 0 plus 2 over 0, and then 0 plus 4. Oh, it looks like we're in trouble here. So I have 2 times 2, and then 0 times 4. The problem is we can never have 0 on the bottom. So in this particular case, it looks like there is no y-intercept. There is no y-intercept. We're going to see why later when we graph this. We're going to see why none exists. Because I already told you previously, there will always be a y-intercept, one at a maximum one y-intercept. And when that doesn't occur, unless there's a restriction on the domain, it's probably because there's a vertical asymptote that's occurring at x equals 0, which we can see. Much easier to understand when we graph it. Let's look at the next one. First, I'm going to start off by asking myself, can I factor? And I can. Oops, that's a negative. I am not able to simplify anything, so there's no hole in the graph. Let's start with horizontal asymptote. In this case, I can see the degree in top is 1, and the degree in the bottom is 1. So I'm going to create a ratio using the leading coefficients. And I have an equation of y equals 2. That's my horizontal asymptote. To determine the vertical asymptote, I'm going to take the denominator and I'm going to set it equal to 0, and I'm going to solve. So I'm going to add 5 to the opposite side, dividing by 2, and I get x equals 5/2, or 2.5. Let's go ahead and identify the x-intercept. We're going to take the numerator and we're going to set it equal to 0. That's the shortcut in this form. Negative 8 equals 4x divided by 4 divided by 4. And we can see x equals negative 2. So negative 2, 0 would be my x-intercept. Let's look at the y-intercept. The y-intercept for this is I'm going to replace all the x's with 0. So y equals 4 times 0 plus 2, and 2 times 0 minus 5. 4 times 2, well, 0 minus 5 is negative 5, and I end up with negative 8/5. That's going to be my y-intercept, 0 and negative 8/5. On to the next one. Ooh, this looks a little bit tricky. So in this problem, I see that 3 is a value that can be factored out of 3 and 6 and 24. So I'm going to factor out 3 to get x squared, subtract 2x, subtract 8. Now let's make sure I didn't make any mistakes. When I distribute, I get 3x squared, subtract 6x, subtract 24. Looks good. and I can factor 2 out, x squared minus 9. Now I need to keep going here. I know that I can ask myself, are there two values that multiply to equal negative 8 and combine to equal negative 2? There are, x minus 4 and x plus 2. And I know that x squared subtract 9 factors into x plus 3 and x minus 3. All of this is beautiful, but notice that I can't, oops, sorry, a small mistake here. I can't reduce any value on top with the exact same quantity or value on the bottom. So there is no holes in the graph. Let's go ahead and let's identify the horizontal asymptote. We have equivalent degrees, so in order to identify the horizontal asymptote, I'm going to create a ratio of the leading coefficient in the numerator divided by the leading coefficient in the denominator. To identify the vertical asymptotes, I'm going to take each one of these quantities, and you may ask yourself, why am I forgetting about this x, or the 2 in front? It's because it doesn't have any x, any variable with it. So I'm only going to take the quantities that have a variable, and I'm going to set them each equal to 0, and I'm going to solve. So I'm going to subtract 3 to the opposite side, and I'm going to add 3 to the opposite side. I have 2 vertical asymptotes. Let's move forward now with identifying what will be the x-intercept. So the shortcut in this form is to take these two, and I'm going to take 0 and set it equal. So I'm going to start by dividing by 3. 0 equals this. And so if this is true, then either x equals 4, x equals negative 2, or maybe that's true for both. So I'm going to take each one of these quantities and set it equal to 0. Add 4 to the opposite side. So 1 is x equals 4. Subtract 2 to the opposite side, and x equals negative 2. Those are going to be our two x-intercepts. 4, 0, and negative 2, 0. And finally, how do we determine the y-intercept? Well, let me go ahead here and just give myself a little bit of space. I'm going to take this form, and I'm going to replace all x's with 0 when I identify the y-intercept. So y equals 3. Okay, 0 minus 4 is a negative 4. 0 plus 2 is 2. 0 plus 3 is 3. 0 minus 3 is negative 3. And then I can go ahead. I could reduce at a time. Like I know 3 divided by 3 is 1. 2 divided by 2 is 1. So I end up with negative 4 over negative 3. Two negatives make a positive. So y equals 4/3 is the y-intercept, written as 0 and 4/3. These last two problems, number 7 and number 8, we're going to start class with when we go over rational functions 2 tomorrow. Hope that helped.